proceed now. Good afternoon, students. Uh, our esteemed guest, Dr. Amit Ganatra, sir, is here for to teach us introduction to artificial intelligence, and then later on we will be seeing genetic algorithms. So we welcome sir to share his knowledge with us. Thank you, sir.
Okay, so good afternoon, everyone.
Good afternoon, sir.
Okay, so
Good
please,
afternoon, sir.
good afternoon. Please make this session interactive, okay? Then and then you will find it is interesting also, as well as you are going to learn. I'm also going to learn from all of you. So make this session interesting and do interact more. Okay, so whenever I ask the question, whomsoever is knowing, please immediately answer. Don't worry about whether that answer is correct or not, complete, incomplete. So you should not worry. So you are aware that everybody is talking about AI, right? Artificial intelligence, and then machine learning and deep learning, which are the sub branches of AI. And then again, deep learning is a sub branch of machine learning. So why everybody is talking about AI today? Can anyone tell me why the environment is favorable today? This subject is not new, right? This subject is introduced way back, and the algorithms, if you see, most of the algorithms are available since more than 1970s, since 1970s. So why, if all these concepts were available, why people have started realizing this subject since last 5 to 10 years back? Okay, starting from 2010 onwards, or after 2006, largely. Why everybody is talking about AI? If that concept was available, okay, why the people have not realized at that time, and why everybody has started talking about AI in industry, in society, right? Everywhere people are talking about AI. So why?
Sir, AI helps us to automate the tasks, and in the past, that it was not able to compute as it requires more computing power.
Mm-hmm.
So the GPUs and all
No,
that
no,
stuff
please come
have,
again, come again, come again. First thing, what you have said, it automate the task,
yeah,
right? So correct. Okay, so all of you please note down what he has said. Yes, here we want to achieve the automation, right? This is the first important role AI can play in industry. So can we replace man with machine? This is what this subject is teaching. So this subject is about replacing man with a machine. Is it like that? Can we replace 100% man with machine?
no, sir.
Mhm. So what is this subject all about? Automation is fine, but why is AI buzzword today, right? Why is everybody talking about AI in industry world, in society? Why suddenly for all the branches, all the people, this particular subject has become so much of important? Any other answer? Why the environment is favorable today?
Sir, because the more hardwares are available to the common people.
Correct, correct, correct. Okay. So there is a evolution in hardware. Everyone agrees with his statement, what he has said. There is a evolution in hardware. You can see that previously we were working with a personal computer. Now we have a cloud computing, right? We have a distributed computing, right? We have a GPU, we have a CPU, we have a TPU. So in CPU, basically we have a 7 core. In GPUs, you have a thousands of cores. So the speed at which you can process the data in GPU and TPU is much more faster than CPU, right? So thanks to the hardware evolution, okay, so we have a fully area network, we have a cloud computing, distributed computing, quantum computing, right? We have a evolution in CPU architecture itself, and we are moving from CPU to GPU to TPU. We have evolution in the storage capacity also, primary memory also, So yes, this is the biggest reason. You can see that that's why people have started talking about AI, because all this evolution which has happened in last 15 years in terms of hardware, right? Largely in India, I am saying. Okay, if you consider the foreign countries or European countries, then you may add 5 more years, because we are always running 5 years late in adopting the technology. So one is chalo, evolution in hardware. Second thing, what you have said is automation. Yes, you can achieve automation, but you have rightly said you cannot replace man with a machine. This subject is not teaching replacing man with a machine, which is not possible. Rather, here in this subject, you are going to study how to develop good synergy between man and machine. Right. So please remember, this subject is not going to teach you about these mans are going to be replaced by the machines, never, right? So here job cuts are going to be there, and all fears what the people have or a myth they have, right? Misconception they have about this subject. So due to AI, millions and millions of jobs are going to be created, right? It is not going to cut down the job, please remember, provided you must have a required skill for this particular subject. Chalo, still I want the answer. Evolution in hardware, automation, right? Yes, everybody wants to automate. So automation of routine task, okay? So operational task. So that you have to not involve yourself in carrying out repeatedly same task again and again. That can be carried out by the computer. But strategic level task, right? Tactical tasks, again, computers cannot manage efficiently, accurately, precisely. There is a evolution in subject itself from AI to ML to DL. Yes or no? Right? Machine learning is a sub branch of AI, and deep learning is again a sub branch of machine learning. So there is a evolution in subject itself has happened, because if you have to deal with unstructured data, if you have to deal with multimedia data, right? Audio, video, image, all this kind of application, the previous algorithms and architectures and frameworks are not going to be not going to work, as well as they are not going to efficiently process the information and transform them into a knowledge. So there is a evolution in subject itself from AI to ML to deep learning, right? There is a evolution in hardware. There is evolution in data transfer technology, right? From 2G to 3G to 4G to now we are soon going to realize 5G. So we'll be moving from 100 Mbps to 100 Gbps network. So again, the challenge is with all the algorithms means what? If you are going to pump the data with this much speed, can your AI algorithm can process the data, which is flowing at very tremendous rate? Means with this velocity, if the data is coming, can same AI algorithm process this much of data? And can this data can be converted into information and knowledge? Right. So now we have use cases, we have money available, awareness is there, everybody is talking about AI, everybody is knowing about AI, at least they have heard this word which was not previously there. All these scenarios were not prevailing in the past before 15 years. So yes, they have a huge amount of data, their capacity to store, acquire and retrieve the data has been increased because of data centers and all that. Now they are not worried about the upfront costing and investment and all that, right? You can store your data or you can keep your data in data centers also. So our capacity to acquire, to store and to retrieve that data very fast has been increased due to evolution in hardware. People have a use cases, people have a money thanks to this data transfer technology, thanks to the evolution of subject itself from AI to ML to DL, right? So these all are the parts which make this subject more favorable in today's environment. That's why everybody is talking about AI. Okay, now what do you mean by intelligence? You just tell me. What do you mean by intelligence?
ability to think.
Ability to think. Mhm. Bolo,
To
any
make decisions.
to make decisions, correct? Next.
make correct decision at correct time.
I am not moving any slide, madam, right now. I have not started moving any of the slides. I have not started moving any slides right now. Bolo, which are the characteristic of intelligent person? This same thing you have to put inside computer. This is nothing but your artificial intelligence. It is
Ability to learn.
a
Ability to learn.
ability to learn. Okay, decision making. The if you are having thought process, right? If your ability to trigger new ideas in your mind, the action which you take, okay, based on the ideas which you are generating. This is how the intelligence is reflected from a people. Okay. So how to convert? Chalo, if you have a data, how do I convert this into intelligence? How to transform data into intelligence? Ultimately, what you see is data, okay? And from this data, you are reaching towards intelligence. Data need to be processed so that it can be converted into information. Then in information, you have to apply the rule so that it will become knowledge. If you have a knowledge, you are a wise person, okay? So that you can take appropriate, meaningful decisions very fast. And when you take the decisions, your intelligence is going to be reflected. Yes or no?
Yes, sir.
So the way we learn, the way we understand, the way we think, if we want to make machine should also learn, understand, think and take the decisions exactly like human, right? That is nothing but the branch of artificial intelligence that is called machine learning. And this is what you have to actually make. You have to make machine exactly learn like a human. And this will not possible unless and until you put logically a brain inside the computer. Right? So this is called mimicking a human brain inside a computer. So that your computer, when I say computer means I am talking about system, software, application inside that, right? But I am talking in general. So you have to always believe that when I say computer, I am talking about the system, software or application or programs. So we want that human brain should be mimicking inside the computer. Then and then it is exactly going to react like a human. So how human brain functions? You just tell me how human brain functions. I am putting more stress on fundamentals. Okay, so once you are clear about that, any other topic you can easily understand. So why you are studying this subject, okay, and how to acquire intelligence. This is what we are learning. I'm not going to cover any topic right now. How human brain functions? Chalo, you just tell me. All of you have a human brain. So how human brain functions? No one is aware how human brain is actually working.
Through neurons.
Through neurons, okay, but right now in front of you there are something. Can you see something? Can you watch? Can you observe? What is in front of you?
Sir, may I go ahead?
Yeah, yeah.
Sir, first human brain receives the data through eye or ears, and then
Yes.
processes on it what we are actually seeing, and after it takes some action
Correct,
regarding.
correct, correct, correct. Right. So there is an input. Right now, whatever you are watching is input in front of you. Okay. So it will take the data as an input. It will acquire the data from the real world. Then it will process. So this is where your one unique algorithm comes in the picture, because every algorithm, every human brain is functioning different way. Like your learning ability is different than mine. Okay, everybody is learning in their own way. So there is a one fixed algorithm in their human brain, and according to that, they are going to learn. So input, then process, and then output. Okay, so right now in front of you, there is a monitor, for example, or a laptop. Is this called classification or prediction? Prediction means recognition. Means are you recognizing or right now are you classifying? For example, in front of me, there is a keyboard, there is a monitor, there is a printer, there is a mobile. So this what I am doing right now in a real time is a recognition or it is a classification? What is this called? Is it called recognition or is it called classification?
Sir, recognition.
Okay, so why can you recognize? How can you recognize this is a monitor or laptop or a mouse or a mobile? How? How it is possible as a human brain inside your mind to recognize this is keyboard, this is mouse? How?
By getting knowledge
Because
about
we
it.
know it before.
I'm not getting, please.
Because we know it before.
I'm not understanding what you are saying.
By getting knowledge about it.
Knowledge about it. So how did you recognize this is this object? This is what I'm saying. If you have to make human learn, okay, human learn means your brain should learn what we should do. How to make machine capable of learning? How do we make machine should learn? How do we learn?
Through experiences.
From
By repeating tasks.
yes, experience. Okay, so experience is different and learning is different. And when you put together both, it is called experiential learning. The difference between you and me, okay? For example, you may be learning more than me, but experience wise, if you consider, and if I put experience plus learning, my experiential learning is far, far better than all of you. Okay, it is called wisdom. Okay, so suppose if I am taking decision and you are taking decision, my decisions, there is a high chance it is mature than your or yours. Because I am not having just learning but experience and learning both. So it is called experiential learning. This is nothing but my wisdom. This is reflected in my decision making. So how do we learn, right? Like for example, there is a pen is an object. So if I put in front of you or present in front of you one object which is called pen, and you are immediately going to recognize this object as a pen. So how do you recognize this is a pen? What has been done in the past? This is what I'm saying, so that now you are recognizing or predicting the object or its class label, which is pen, out of millions and trillions of objects which are prevailing in this world. How do you recognize apple? How do you recognize tomato? How do you recognize cow? Any object. Hmm?
Sir, in past.
What? These objects have been presented in front of you by your parents, by your teachers number of time that this is apple, this is apple, this is apple. So there was a training, yes or no?
Yes, sir.
So training has been done on both the object as well as label. Please understand what I'm saying. So if this is a red and round and this kind of object, then this is called apple, right? So there is a object as well as label on both. The training has been made, has been done, and these objects have been presented in front of you number of time. This is called your training time. Okay, this was offline training, but now when similar kind of object has been presented right now, suppose if I am going to present apple in front of you, you all are going to easily recognize this is apple. It is called recognition or prediction, which is happening in real time without wasting any single moment, without any additional training. So we are investing for past, but we are making our future secure. Please remember, in this subject, we are doing a lot of offline training by providing similar kind of data. It works on principle of similarity. Like learning is never going to happen if you are going to present all different kind of objects. You have to present similar kind of objects until you recognize the object. Now everybody's IQ is different, everybody's learning rate is different. For someone I have to present 50 number of times, for someone I have to present 30 number of times, for someone I have to present 20 number of times, and they are going to remember, and their training will be over. So those who are having average IQ, those who are having good IQ, those who are having below average IQ, that is what we are calling slow learner, medium learner, fast learner. So the training time for slow learner should be smaller or larger?
Larger.
Okay.
Larger.
Yes, and training time for fast learner or those who are having good IQ should be. So what do you mean by this? They require less time. Okay, so less time in training, less number of objects by which they are going to recognize the objects. Right? So that is called learning rate. So suppose if I am a slow learner, I want to become medium learner, what should I do? Right, in your class we have all kind of people, so you should not worry whether you are a slow learner, medium learner, fast learner, but you have to put the efforts, you have to keep the momentum, you have to increase your speed of learning so that you can learn faster, so that you can jump from medium to fast learner or from slow learner to medium learner. So what should I do? You just tell me. Chalo, I am a slow learner, I have recognized myself. What should I do? I want to become medium learner or fast learner. What should I do?
We can do more training.
Exactly, right? So suppose if I am teaching today, whatever I am going to teach, those who are fast learner, they are going to remember 50%. Those who are medium learner, they are going to remember 30%. Those who are slow learner, they are going to remember only 15 to 20%. So what they have to do, those who are slow learner, they have to repeat my PPT 5 times. Those who are medium learner, they have to repeat 3 times, and those who are fast learner, they have to repeat only 2 times. So this you can recognize for a person. Okay, how do I recognize for system? You just tell me. Because we are mimicking human brain inside computer. This is what is our whole subject. The tasks which are carried out by human can be carried out by computer. That is nothing but the subject called artificial intelligence. It is not the actual intelligence. It is the intelligence of the man or the person who is actually developing that system, which is reflected inside your computer. Right? So basically we want to mimic human brain, and that's why we are developing this system so that it will exactly act like a human. It will think like a human, right? It will learn like a human. It will take the decisions like a human. We want machine should learn exactly like a human. That is nothing but a machine learning. To achieve AI, we have to make machine capable of learning. That is called machine learning. Then and then it is going to work in an automated way. Otherwise not. Hello?
Yes, sir.
Please speak up.
Students, please.
Answer. So here we have to engineer intelligent program. Now, any problem which does not require intelligence cannot be a part of artificial intelligence, right? The problems you have to classify which really require human intelligence to solve that problem, which can also be only classified as an artificial intelligence problem, not all the other problems. Please remember. So if you have a sorting algorithm, you have a searching algorithm, which you have studied in data structure, where you have a well-proven procedures, algorithm, everything is available. Can we classify this as a AI problem? Can we consider this as a part of artificial intelligence? Like your scheduling algorithm in operating system, where everything is known in advance, you have to just convert that into any programming language by following the syntax. Can we classify this as a AI problem? Where the intelligence is there in, you just tell me. In scheduling algorithm, where all the algorithms are given, in sorting algorithm, in searching algorithm, everything is given, where intelligence is required to be applied. You just tell me. I have to just take it by following the syntax of any programming language. I can convert that into a program. Do we require intelligence?
No.
So tell me problems which really require intelligence to solve the problem, where the human intelligence is required, which are classified as a AI problem. Give me some examples.
Classification problem.
Classification problem. Okay. Next.
Problems where cognition might be required,
Like, can you give some real world?
like if some involvement of human senses or
Okay.
some experience is required.
Suppose chess game. Chalo, I want to develop chess game. Can we classify it is a part of artificial intelligence?
Yes, yes, we can.
Tic-tac-toe game.
Yes, it can be.
It can be. Okay. Suppose you want to recognize my mood. Suppose you want to approach me for granting your leave, right? But before that, you want to see whether my mood is okay or not. So you can take an image, okay, from mobile outside my room, and you can see that whether my mood is happy, sad, and based on that, you are going to approach. Is it a part of AI or not?
Yes, it is.
Person recognition, speech recognition, mood recognition, okay, translation of language from one form to another, image classification, tracking objects, okay, from video. So please remember that any problem cannot be considered as a part of AI, right? The problems which really require human intelligence to solve that problem can only be classified as a part of AI. So here we have to engineer the machines and program, okay? So that machines and program we have to make intelligent, right? And when I say engineering means you have to start from planning, then you have to acquire the information, analysis, design, implementation, testing. But here you have to make intelligent machines. When I say machine means the programs or system or software or applications which are running inside that. So this is your subject. Here you have to develop programs, but this program should be intelligent programs, right? Which really require human intelligence. Otherwise, if you have to solve it, right? You have to put brain inside computer. Then and then there is a win-win situation, right? Like human brains are good in terms of association, in terms of noise tolerance, in terms of parallel processing. Like I am right now taking lecture, but thinking in so many possible directions at the same time. So this is what is the strength of human brain, but computer is a sequential processing. It cannot parallelly process all this data or information, right? So human brain is good in terms of parallel processing, association. You are aware about my association with you. You are aware about your association with your parents. So relationship, association, this is where human brain is good. Noise tolerance, like if this AC is making a noise, still I can tolerate. So these all are the parts where human brain is good. right? Where computer is good, calculation, fast calculation, precision at which it will do the calculation, memory, right? Like if we become older, our biological neuron may die, and because of that, our memory may become weaker, and we may forget. But computer will never. Okay, once you store in a hard disk, if you have proper backup, or if there are no bad sectors in your hard disk, the information will be stored for whole life, forever. So if you logically put brain inside the computer, means mimicking a human brain inside a computer, it's a win-win situation, right? Computer is good where human brain is not good, human brain is good where computer is not good. That's why we are simulating human brain inside a computer, and that is nothing but our artificial neural network. So most of the learning is always happening via human brain inside the human body or in a human. So same thing, if you have to make machine learn, machine means the program, application, system, software, then you have to put logically brain inside the computer. That is nothing but artificial neural network. So for learning, the most important concept, right? If you have to make machine learn exactly like a human, it think like a human, they take the decision like a human, then you have to implement human brain inside the computer, you have to simulate human brain inside the computer, and that is nothing but artificial neural network. Right? So then we have a sub branch called machine learning. How we are learning, we have to make machine capable to learn, think, take the decision. And then we have a deep learning. Deep learning is called self learning from huge amount of data. So please see that from AI to machine learning to deep learning, when you are going, then your data requirements will become larger, right? So in AI, you can work with MBs of data to train your system. In machine learning, you require GBs of data. In deep learning, you require terabytes amount of data, petabyte amounts of data, right? But coding is less. You see, data requirements are going to increase from AI to ML to DL. But your coding in AI is, you require more amount of coding in AI. If you are going from AI to ML, you can straight away use framework, libraries, and you can do little bit of coding, and you can achieve machine learning. The way we learn, we should make machine capable of learn. And then we have a deep learning. Deep learning here, no coding is required. It will learn from data. So it's a self-learning from huge amount of data. Right, so here feature extraction and everything is incorporated inside your algorithm. In machine learning, you have to extract the features. Like if there is a apple, then it is a red, it is a round, such kind of features you have to hand code. While in deep learning, there is no need to do any kind of coding, there is no need to do any kind of feature extraction. It will be automated 100%. You have to just supply the huge amount of data, and your system will automatically learn from huge amount of data. So it is called self-learning from huge amount of data. Right? So AI is a superset, machine learning is a subset, and again deep learning is a subset of machine learning. So there are certain limitations of machine learning, because if you have multimedia data, like if you have image, audio, video, then your machine learning algorithm will take a lot of time. I'm not saying impossible. And that's why if you have a deep learning, then it will become more efficient. That's why you require deep learning architectures, right? So this all CNN, RNN, LSTM, restricted Boltzmann machine, that is RBF, RNTN, GAN, these all are the various kind of deep learning architectures or deep neural network architectures which are part of deep learning, which is always used to deal with huge amount of data, terabyte, petabyte amount of data, whether it's a structured or unstructured, right? Whether it's a text data, wave data, or multimedia data, and it will give you insight out of that. So see that this is all are the areas where AI is applicable. You just tell me one area where AI is not applicable. And that's why everybody is talking about, because everybody would like to get the insight about their data. Okay, they want to automate their processes, the routine processes, operational processes. So chatbot is an example, right? For example, if you are making a phone call for admission inquiry in any university, then you feel like you are talking to some human, but actually it is nothing but a machine. It is nothing but a computer. So there are list of questions on which this computer is trained. So if you are going to ask similar question, it will exactly reply the way you have noted that reply for that specific question. So every industry right now thinking for the automation, right? So it is exactly like they want to make machine capable to learn, not only learn but adapt. The machine should not do similar kind of mistake what it has done in the past. So it is called adaptive, right? They want not only want to make machine learn, but they want to make it adaptive also. So this is how learning is actually happening. As I have already said, for learning you require input processing, right? So whatever your brain can see, it has to process all this input what it perceive. Okay, and everybody's learning style is different. Okay, somebody is learning by watching the video, somebody can learn by developing a project, somebody can learn by attending a lecture. So everybody's learning style is different, everybody's learning rate is different. So here in this particular subject, we have to build the learning algorithms that exactly mimic the human brain. Okay, but here there is a computer. So how do I recognize what is the best learning way for this computer or this application or system or software? What is the learning rate? Okay, whether it's a medium learner, fast learner, slow learner. For human, I can interact and I can find out whether you are a fast learner, medium learner, or slow learner. Okay, by seeing your CGPA, by seeing your 12th result. But how do I recognize computer like this, whether this is a fast learner, medium learner, or slow learner? So I have to do trial and error. I have to experiment. I have to supply all these parameter. Okay, so I should start with lower learning rate and I should gradually increase the learning rate, and I can find out the optimal value of learning rate by which I can say that with this learning rate my computer is learning the most. So everybody is having one learning algorithm which is fixed, and this learning algorithm we have to fit inside computer so that it will also learn exactly like a human. So we have to build in this subject learning algorithms that mimic the human brain, then and then it is capable by that machine to take the input. So it will acquire the knowledge, store the knowledge in human brain the way we are storing. So it will be stored in the memory, and then it will be disseminating this knowledge. Means you are giving the output. Okay, the way you are recognizing right now: monitor, laptop, keyboard, mouse, phone, table, chair, fan. So this all you are recognizing at the same time. This is what is the strength of human brain. Human brain is capable of processing so many information at the same time, right? It will recognize so many objects at the same time. So here more the data, you can see that bigger the data, the more the training, this is better. Okay, so that you can learn in a better possible way. Now there is a Turing test. Okay, so how do I recognize whether my system has learned and it is intelligent or not? When should I stop training my system? This is the obvious question. Okay, so while presenting the object apple also, your parents have validated or tested. Okay, so after presenting that object number of time, after few time they have again validated or tested by presenting same object again. Okay, and if you have recognized correctly, means now they are rest assured that they are sure that now in future also, whenever this kind of object which is similar to something on which you have been trained and tested, if it is going to be presenting in front of you, or it will be presented in front of you, you can easily recognize it. So there is a Turing test, okay, to just check whether your system has learned properly and whether it has acquired the intelligent behavior or not. So it is the example like I have given chatbot example. So actually we are making a person fool. Okay, fool in the sense what? When he makes a phone call, he thinks that he is going to interact or he is interacting with a human, but actually it is a machine. So if that person cannot recognize whether he has interacted with a person or a machine, but actually it was a machine, then you have achieved the intelligence level. Means your system is intelligent enough and the system has learned properly. This is called Turing test. So any program which passes the Turing test means if you can make the person full, okay, that person is interacting with a machine, but he or she feels like he is interacting with a human. Means you have developed very intelligent system which can fool the person. So here you see that Turing test is what? Any machines makes you believe it's a human. Ultimately, it is a machine, but it makes you believe you are interacting with the human. Fine. So any problem in AI, there are two important things, right? First thing is what? You have to logically put the brain inside the computer. Means it is mimicking the human brain. Mimicking human means what? The most important organ is human brain. So the way we think, understand, learn and take the decision, we expect that the machine should also learn, think, take the decision exactly like a human. And second thing is what? Once you have made the system, you have to see that your program which you have developed or system or software which you have developed, it must pass the Turing test. Right? So it makes you believe it's a human, but ultimately it is a machine. When you talk about machine learning, as you have said, as you are gaining the experience and you are learning, so your IQ is every day modified. So right now you are a better person than yesterday, and you will be better person than today, tomorrow. Okay, so learning from experience, learning with experience is nothing but a machine learning. So you have to not only learn, but you have to adapt. You should not commit the same mistake which you have committed in the past. So if you play tic-tac-toe game, please try to defeat that game by following same sequence of move by 2 to 3 times. What will happen? 4th time it will learn. And if you try to defeat, then you are not allowed to defeat that game. Right? So this is what is the way we adapt, the way we learn and adapt. Our system should also learn and adapt. It is nothing but learning with experience. Learning from experience is nothing but your sub branch of AI. It is called machine learning. Right? Here we are making machine capable exactly learn like a human. And as I've said, deep learning is here you require huge amount of data without doing any kind of feature extraction, without doing any kind of explicit coding. If you are learning from huge amount of data, then it is nothing but a deep learning. Right? So here in AI ML DL, lots of data need to be parsed. And this is what is a Turing test. Previously, right? So this Alan Turing has come up with this concept. So there are two rooms. In one room, there was a person. In another room, there is a computer or a machine. Okay. Both the rooms were closed. The person outside both the rooms, their doors were closed, has to ask the question. Answer may gradually come from any of the room, right? But if that person is not judging whether the answer is coming from a human or from computer, or if you can make that person fool, right? And if that person cannot judge whether the answer has come from a machine or from a human, and he accept the answer, means your system has passed the Turing test. So in artificial intelligence here, right, this is a very important subject of computer science. So again, AI is a subfield of computer science. So whatever task that we are carrying out today, we expect that machine should also carry out similar kind of task. So here is whatever task I am carrying out right now, right, I want to make it automated. This is to be done through computer, right? So computer is just going to assist me in making my decision making process automated. I'm not replacing man with a machine, right? The way I adapt, the way I learn, right? You can't just compare. So here, whatever tasks which are carried out by the human, we expect that computer should similarly carry out all these tasks. That subfield or sub branch of computer science is called artificial intelligence. It is not the actual intelligence of the machine, it is a man-made. The person who has implemented the system, like his intelligence is reflecting. So if you play the chess game, if you play the tic-tac-toe, if you play the cricket game, okay, so you are feeling as if like you are sitting in front of your friend and you are playing, right? And it is a computer application and the intelligence is fed by that person, right? So the intelligence and the intelligence level is reflected of that person or the group of persons, those who have developed that program or application or system or software. It is not the intelligence of the machine. That's why the word is artificial, right? We have actual intelligence, real intelligence, while computer is having artificial intelligence. It is exactly going to react the way it is programmed, the way it is going to learn, right? So your intelligence is reflected in the computer or the computer programs. So no one can claim that my program is the most intelligent. Okay, if any other intelligent person is going to develop or has to develop similar program, he may come up with better program than what you have developed. So sometimes you can defeat the computer, right? Or sometimes that computer can defeat you. It depends on the intelligence level, whether you are having more intelligence than that person who has developed that program, or that person is having more intelligence than the person who is playing in front of computer by sitting like you also. Right, so this all are the important thing. You can see that here you have to make machine capable of learning exactly like a human. Here you have to process symbol. So there is a symbolic processing, text processing. Okay, sometimes you have to give the instructions also. You have to process the image also, video also. Okay, so there is a full sub branch called computer vision. Robotics, all of you are aware. Right now, the robotics are assisting doctors in surgery also. And you have seen there are so many robots which will also give you information about some universities and all that. In any of the event also, you are aware that government events, there is a Mitra, which is a robot which will give you and give some direction and assisting you in some of the functionalities. So robotics, your game playing, computer vision, right? Pattern recognition, right? So here you see you require the knowledge of advanced mathematics and statistics. So pattern recognition you can do better with deep learning, right? So your audio, video processing, multimedia kind of applications you can deal with deep learning. Of course, statistics and advanced mathematics knowledge is required. Now, speech recognition, NLP kind of applications can also be dealt with artificial intelligence or machine learning, right? And you can use various kind of model, CNN, RNN, right? And again, with the help of CNN, you can solve the problem of computer vision like image classification, object recognition, object tracking, etc. So this is what is an evolution which has happened from AI to ML to DL. Okay. So this all are the prerequisite in AI. You require huge amount of data, as I've already said, right? In AI to ML to DL, as you are going down, the data requirements are going to be huge. You must have a knowledge on advanced mathematics and statistics, computer science subject like data structure, design and analysis of algorithm, etc. You must have a domain expertise, right? Like suppose if I want to implement chess game, then you should be aware about each and every rule, moves about chess game. Otherwise, you cannot implement that. So domain expertise, you must have a good domain knowledge about each and every field, right? Like suppose if you want to automate the industry or processes, then you must know that processes and industry first. Computer vision with audio, video and all that. And the predictive analytics, which is the most important functionality of machine learning. You want to forecast, predict the future based on your past data, right? Like stock price prediction, your weather forecasting, crop yield prediction. These all are the applications. Okay, now what comes under AI? So in this whole semester, you are going to learn this many topics in this subject, right? You will be learning certain searching algorithm. Like today, we'll see genetic algorithm, right? And colony optimization, particle sum optimization, simulated annealing, nearest neighbor, branch and bound. So these all are the various searching techniques. So searching means what? There are so many legal possible solution for a single problem. Okay, which is the best out of all? This is what you have to search as fast as possible. This is called search. This is called searching problem. So we have a search space, okay, or a state space. So here we have so many possible solution, legal possible solution. Out of that, which is the optimum solution? Okay, this is what you have to search. And these all techniques what we were searching, we were talking, they are the search technique. They are called optimization and search technique, right? Whether you talk about GA and colony and A star algorithm, AO star algorithm, base first search, and so on and so forth. So there are so many possible solutions for a single problem. In a chess game also, you are aware that you can defeat, checkmate, stalemate. There are so many possible ways by which you can do it. So which is the best out of all? This you have to search. That is called your searching problem. Then how to represent knowledge? and how to give reasoning explanation about it, right? No one is going to believe otherwise. So reasoning means what? You have to give the explanation, justification. So knowledge representation, and you have to also give the reasoning. Then planning. Okay, so you see that planning really require intelligence. If you have to present your knowledge also, you require intelligence. If you have to search out of so many possible solutions, you also require intelligence. So you got this academic calendar. Okay, so before you get the schedule, we have to plan. And this planning really require intelligence, right? So that not a single entity of teaching, learning, examination should be missed by us. So any kind of planning, right? When you do the planning, it reflects the intelligence of that person who has done this planning. And the word is planning. Please see that it's not a plan. Please remember, planning means what? I should not be rigid, right? If something is going to happen, and due to that, if I have to change the examination date or something, then we should immediately change it. That's why it's a continuous, right? Then next is machine learning. The way we learn, we have to make machine capable of learning. So there are 4 types of learning. So machine learning is a sub branch of AI. When you study machine learning separately, there is a supervised learning, classification, unsupervised learning, clustering, association rule mining, dimensionality reduction. These all are part of unsupervised learning. Semi-supervised learning, which is a combination of supervised and unsupervised, and reinforcement learning. When you learn by interacting with the environment, when you learn based on reward and penalty like game playing, robotics, self-driving car, these all are the applications of reinforcement learning. So machine learning means what? You must have a knowledge about statistics, advanced mathematics, and you will be learning all 4 types of learning: supervised, unsupervised, semi-supervised, and reinforcement learning. Natural language processing, like right now I'm speaking English language, right? So from speech to text, text to speech, I can convert English into Gujarati, Gujarati into Hindi. These all are the example of natural language processing, right? You have to process the natural language. You can extend that to text analytics like recommendation system, sentiment analysis, right? All of you are aware about today whether the sentiment is positive, negative, neutral about the movie or product, right? You will immediately get the reviews and all that. Expert system, there is a scarcity of expert in this society. All of you are aware. Experts are very less, and if you want to avail the expertise of that person to each and every corner of the society, then you have to interact with that expert. You have to capture his or her knowledge, and you have to feed inside the computer, and that computer is going to exactly act like that expert in his absence, right? Because that person cannot reach to each and every corner of the society. So such kind of system, if you are going to develop where there is a less experts are available, that is nothing but your expert system. So again, you are aware that 100% replacement cannot be possible, but it can serve temporary purpose, right? And you have to regularly interact with the expert, and you have to feed new knowledge also. So knowledge update is biggest challenge in expert system. It's not one time job. All right, then you can interact with the environment. So we have a robotics, we have a computer vision, we have a speech recognition kind of application, which all are part of AI. So these all are the topics which you have to learn, like game playing, planning, searching, knowledge representation. Okay. Machine learning, natural language processing. Okay. You can add also learning, artificial neural network, fuzzy logic. So if you have to move from imprecise or uncertain situation into precise and certain situation, you have to use fuzzy logic. Okay. So computer only works on binary logic like 0 or 1. But you are aware that in real world, we always used to use some fuzzy words. Like if I say move your leg slightly, how computer will understand that? That slightly maybe 10 degree, 15 degree. Okay, so instead of working with either 0 or 1, if you work with set membership of value between 0 and 1. So here you can see that value is 0.15. Right, so this is how you can make your system much more precise. Rather than working with only 0 or 1, you can have a set membership of value between 0 and 1. So you can take any of the value and you can instruct computer so that it will exactly work precisely. That is called fuzzy logic. So when you put together this all, it will make your curriculum of AI. Right. So here you can add game playing, here you can add learning through artificial neural network. right? This all, if you put, it will make your overall curriculum. Fuzzy logic, if you add for precise and certain situation, you can add statistical reasoning also. Okay, so in statistical reasoning, we have a new Bayesian algorithm kind of things. This is going to find out the probability. For example, what is the probability of rain for today? So how do I find out? Like today, on a similar date in last 10 years, how many times rainfall has occurred? So let us assume that out of 10 times, only one time has been rainfall occurred. So it is 1 upon 10. So there is a 10% chance that rain will occur today. So this is how you can find out the probability, right? So the probability theory, and if you are going to study all and based on past, if you are going to predict your future, then this kind of things are a part of statistical reasoning, right? So if you are going to study all that, which is also a part of AI. So this is what you have to study in this whole semester in artificial intelligence, right? And these all are the types of learning, as I have said, supervised, unsupervised. You can also combine both semi-supervised, which has recently emerged, and then reinforcement learning. The representation is either attribute based or you can have a relation based, that is schema based, table based, right? And use of knowledge, either it is empirical, either it is analytical. And these all are the areas of AI. You can see the relationship. You can search out of which solution the optimum solution is, right? Logic, all type of logic, monotonic, non-monotonic, fuzzy logic, binary logic. So all types of logic, knowledge representation. We have predicate logic, we have propositional logic, machine learning, all types of learning, planning, computer vision, natural language processing, robotics, right? Learning with neural network, expert systems, fuzzy logic, so which is a part of logic. So this all, when you put together, it will make the curriculum of AI. And this all are the few books. Ritchie and Knight is a very popular book. Second author is Winston, Norving and Russell. So these are the few good books which are available in our library, right? Which you can issue. So which book is good for which topic also have been presented. So these all are the various definitions of AI, various understandings about AI from the various people. See, here we have to build intelligent entities. Some people are saying getting computers to do tasks which require real human intelligence, right? This is what I've said. So the applications are what? Face recognition, you have to navigate a busy street, understanding the someone, what he says, this all really require intelligence. And this all tasks require reasoning on knowledge. Please remember, no one is going to accept only the answer or what part. How and why is also important. That is called reasoning. So you have to give explanation about how you have converted the input into output. That is called reasoning. So there are two main goals of AI. You can see that you have to understand the human intelligence in a better way and to create useful and smart programs able to do same tasks that would normally require a human expertise or intelligence. Right? So any XYZ problem cannot be classified as a part of AI. Only those problems which really require human intelligence and expertise to solve that problem can only be classified as a part of AI problem. Right? So here no algorithms are known, nothing is known. It is going to reflect through your intelligence how better solutions you can provide. So you require this whole, all this disciplines knowledge, right? You must have a knowledge in computer science, psychology. So psychology is not, your human reasoning is not going to come if you don't have a psychology. Philosophy, right? So your nature of belief, rationality, etc. It will come from your philosophy. Linguistic means if you are not aware about language and all that, structure, meaning and everything about language. and human biology, that is how human brain is actually functioning. So this subject has been drawn, or it is this subject draws on ideas from each discipline. So it's a multidisciplinary subject, right? You must have a knowledge on computer science, psychology, philosophy, linguistic, and the human biology. Right? So here there are certain examples which are given. So there are certain expert tasks and there are certain routine tasks. Okay, so you can see that you have to plan a route and sequence of stop to visit. Also, you require intelligence. You have to recognize the buses through vision. You have to recognize the people, the communication, right? Your natural language also, it will reflect your intelligence. And you have to navigate the obstacles on the street and manipulating the objects for purchase. This all require the intelligence, whether it's a routine task or an expert task. Medical diagnosis, you are aware that experts, all the doctors, without intelligence, they cannot serve the patient, right? And if you have to repair the equipment also, someone may require 1 minute, someone may even after 2 hours, he cannot repair. So you can easily understand by seeing the equipment, intelligent person can easily recognize what is the problem. So these all are expert tasks, these all are routine tasks, but still you require intelligence for both kind of tasks. Right. So here there are certain issues. Can a machine be truly made intelligent? Right. And when we should stop training? Such kind of question. Another important thing is what? There are certain problems where humans are not good, nor computers are good. Can we solve by using AI? Another problem, if you watch robot movie, right? If the machine is getting trained on advert thing, like if you watch that movie, that robot has also learned the emotion, then what will happen? Right. So in a Turing test also you can challenge. Can someone tell which is the machine when communicating to the human and to a machine in another room? If not, can we call the machine intelligent? So these all are the questions which are yet to answer. You are all aware that the other side is always going to be there, and but still this subject is not for replacing man with a machine. Rather, how do we have a better synergy between man and machine so that you can come out of your routine task that can be dealt by the computer. The way you take the decision, like the way you learn, understand, think, and take the decision, your computer should also learn, think, understand, and take the decisions. So yes, you can solve any of the task, and that's why everybody is talking about AI. You see that every field, every task you can automate, but 100% replacement of man is not possible. This subject is not for that also. But yes, we can achieve some form of automation and same decision making, the way we adapt, the way we learn, the machine should also learn and adapt. It is not the actual intelligence of the machine which is reflecting. That's why the word is artificial, right? It is man-made, and the person who has implemented the system, whose intelligence is reflected, and that's why the word is artificial intelligence. So basically, we have to put the human brain inside computer. So it's a win-win situation. The way we learn, so that machine should also learn. Right. So this is the introduction about this subject. So my task was not to cover any of the topic, but rather to give the overall introduction about what is AI, why everybody is talking about AI, what is AI, ML, and DL, which are the differences and all that. Okay. Now we are moving to the genetic algorithm, okay, which is a specific topic. So gene, right? All of you are aware, we always talk about the gene structure, that is protein structure, right? Kosh, what we call in Gujarati. So all of you are aware that individually, like me also, and all of you individually have been made from the parents, right? We have been created from our parents. So if you individually compare yourself with your either mother or father, you are always going to be better than your mother or father. Why? Because we have inherited the features from both mother and father. So mother and father have made, and the individual person like us have been created. So this is we call our generation. Our parents we call their generation. Okay. So here also we use same terminology. So all these concepts have been borrowed from real world. So we here expect the way we have been created from our parents, and we are individually better than either mother or father. If we have a two solution, and if we combine two solution, we can have a better solution. Then we have a two better solution. If we can combine, we have a base solution, and we have a two base solution. We combine, then we have a the base solution. So this we have to iterate the way like our grandparents, grandparents, then parents, and then you, and then your next generation, and so on and so forth. It is similar kind of concept we want to apply inside computer. So if you have a two solution, if we can combine, we can have a better solution. Right? So this is what we call, so here we are going to combine certain solution to create a new solution in a hope that this newly created solution is going to give you better result than the previous one. So this is a searching problem also. It is applicable to searching problem also and optimization problem also. For example, I want to travel from Changa to Nadiad, right, to my home. There are so many possible paths. There are so many possible ways. So which is the optimum one? Okay, so of course the total distance travel should be minimum. My cost should be minimum. So if I go via Valetwa to Nadiad, it is the shortest one. But there are so many other, right? Like, and I can go from this other places also. So there are at least 8 to 10 different routes by which I can go to Nadiad. Okay, so I can go to Kaloli, and then from Kaloli I can go to Vaso and Peej, and then also I can approach Nadiad. From Valetwa I can go to Bandhani, and from Bandhani to Anand, and I can again go to Uttarsanda and then to Nadiad also. Okay, from Vartal also I can go, right? So from Valetwa to Vartal, and then to Uttarsanda, and then to Nadiad. So there are so many possible solutions for a single problem. So suppose I am a traveling salesman problem, I have to visit this all city and I have to come back to my original or home city. And my condition is your total distance travel should be minimum. So cost of traveling should be minimum. So this kind of problem can be solved by genetic algorithm. Right. So when I talk about optimization problem, there are two types of optimization. Optimization problem can be minimization problem as well as maximization problem. So the problem which I have talked, like traveling salesman problem, is an example of minimization problem, right? But knapsack problem, like suppose if I have a bag and I have to keep maximum number of objects inside that. So this is also an optimization problem, but it is of type maximization problem. So please remember, when you talk about any optimization problem, which is of two type, either it is minimization problem and maximization problem, and here you can apply in any of the problems. And this is not the only techniques, right? But this is the most popular in today's world. Ant colony, GA, and this particle sum optimization, which all are the newer one. But whatever it is given in your book, these all are prevailing, but right now people are not using, like branch and bound, nearest neighbor, A star, AO star, base first search, simulated annealing, hill climbing. These all are the techniques which were prevailing and it were used in the past. Fine. So there is always a need for better search and optimization technique in every field, but there are very few methods that work better and faster over a huge bulk of information. So this genetic algorithm is going to take GBs of data and it will give you quick result also. So genetic algorithms guarantees faster and better access to huge information in a very robust manner. Right. So what is the objective? As I have said, to find an optimal solution for a problem in a quick time. See, there is an exact solution, there is an optimum solution. So suppose if I say what is the cost of traveling from here to Nadiad, And if you just tell me in a very quick time that roughly it may ranges from 10 rupees up to 4 lakh rupees. If I go via joint auto, if I go via hiring helicopter, any between this in a quick time. Second is what? You can give me the exact price from each and every mode by traveling from each and every mode after 2 days. So right now people are not looking for exact solution after a long time, but they are looking for quick solution that is optimum solution in a quick time. Okay, so this is near exact. I am not saying exact, but near exact, but it is going to give you in a quick time. Genetic algorithm are a heuristic procedure. Heuristic means what? There is a dictionary meaning of heuristic is what? If you are going to improve your future based on your past, means your knowledge, experiential knowledge, and based on that every time you are going to learn and adapt, and based on that you are going to react. Right? So they are the heuristic procedures. They cannot guarantee. Please remember, GA itself does not give guarantee. It is totally up to you how you design genetic algorithm. So GA will give you all the procedures, all the components, but it is up to you how you are going to design the genetic algorithm, because it is a problem dependent. As I've said, for traveling salesman problem, the objective function may be different. For knapsack, the objective function may be different. So for every problem, you have a different kind of objective or cost function. And it is totally up to you, right? So GA does not give any kind of guarantee, but they are able to find very good solutions for a wide range of problems. These all are the goals of GA, right? To abstract and rigorously explain the adaptive process of natural system. This is what I was talking about. Only those organisms which are fit, they will survive. Other organisms will be die off. This is the Darwinian natural principle or law. All of you are aware. So weaker ones are going to be die off. Stronger ones are going to be alive. So this is what we are also doing. Those solutions which are weaker, not good, poor, we are going to remove them, and those which are good, better, they are going to survive. Right. So here we have to design artificial system or a software that retains the most important mechanism of natural selection. So what do you mean by natural selection? Only those who are fit, they will be selected. And if fit are going to allow to reproduce, they are also going to reproduce more fitter individual. Right. So they are robust and they are adaptive also. So try to see that many of the real world problems cannot be solved in a polynomial amount of time, right, by using the deterministic algorithm. And sometimes near optimal solutions that can be generated quickly are more desirable than optimal solutions which require huge amount of time. So here we are looking for near exact solution, near optimal solution in quick times. So genetic algorithm is a randomized search. The difference between random search and randomized search is what? Here initially you have to start with a random, but later on it will get the direction. And after that it is a directive search. So it is random plus directive, that's why it's a randomized search. It is optimization and search technique, as I already said. So it is used for the problem which require the optimization, that is minimization problem as well as maximization. It is going to work based on the concept of natural selection and natural genetics. You can see that the principle which we follow in real world, and you are aware about the Darwinian natural selection law. Only those organisms which are fit, they are going to survive and reproduce. They are allowed to reproduce. Okay, so that they can also reproduce fit individual. And here it can be used to solve NP hard problem, right? Non-deterministic polynomial kind of problem. So the problem which cannot be solved in a polynomial amount of time, that's why it is called non-polynomial. Okay, and it's a hard problem. It's a very difficult problem. Otherwise, it will require whole life to solve that problem. So as I have said, the problem which involves the identification of an optimal value, which can be either minimum or maximum of a given cost function, is known as optimization problem. So optimization problem is either minimization or maximization problem. And the algorithm with the property, the result of every operation is uniquely defined. They are termed as deterministic algorithm. But here you are aware that you cannot determine anything in advance. So it's a non-deterministic and you cannot solve that problem in a polynomial amount of time. It may require exponential time. Otherwise, right, if you are not going to solve with genetic algorithm. So this is what is my non-deterministic polynomial part. So let us see the traveling salesman problem, and this is what I was talking about. You see that there are so many, this one red circle is a one possible solution for the problem. So a randomly generated population of individuals will be randomly distributed throughout the search space. It is called the sample search space. So out of that, which one is the best solution or optimal solution? This you have to find in a quick time. So this is what you have to search in an optimum way. This is for which genetic algorithm can be used. Right? So what do you mean by search space? As I've said, the space of all feasible solution for a specific problem. It is called search space or state space. And each point in this search space represents one feasible solution, right? So this is one solution. One red dot is a one solution. And each feasible solution can be marked by its value. It is called fitness. Okay, so here logically we have to assign the fitness, and whatever or point for which whose fitness is better, they should be allowed to reproduce. And those who are fit, if they are allowed to reproduce, they will also produce the fitter one as an individual. So we are looking for our solution which is only one point out of all this. So ultimately we have to, or we should end it with one point out of all this point. So let us see one example. Okay, there is a traveling salesman problem who has to visit 4 cities, A, B, C, and D. So this person has to visit 4 cities in such a way that your total or that person's total distance travel should be minimum. So here you can see that in which order he or she should visit all the city so that your total distance travel should be minimum. So which are the possibilities? You can see that here the possible configurations to find out the optimal solutions are, suppose if we can start with ABCD, ABDC, ACDB, then ADBC, ADCB, and ACBD. So here you can see that if there are n cities, here you have n minus 1 factorial possible configurations which are there. Okay, so 4. So here you can see that if there are 4 cities, then 4 minus 1 factorial. Okay, which is the answer. So 4 minus 1, 3. 3 factorial means 3 into 2 into 1. So you can see there are 6 possible configuration or 6 possibilities are there. So when n is small, it is fine. Okay, but when n is large, let us see. So let me show you that if n is small, it is very easy to find the optimal solution. But when n becomes very large, then the actual problem starts. So if we assume that computer can evaluate 10 raised to 10 configuration in 1 second, how long would it take to evaluate all the possible solutions of n? So here you can see that if we have 16 city, 130 seconds. If we add one more city, almost 1 hour. If we add only one more city, then it will take 10 hours. Again, 2 cities, 140 days. And for 25 cities, if I add 5 cities, it will require almost 19,60,067,428 years. With the similar speed of computer, if I can work, okay, to find out all the configuration of 25 cities. So it is 25 minus 1, 24 factorial. If I have to calculate, it will take this much amount of time. Imagine. So this kind of problem can be solved in a fraction of second by genetic algorithm, right? Otherwise, this kind of problem would require whole life. And still you cannot guarantee that the solution can be generated by that computer. So this is what is the strength of genetic algorithm. So nearly 2 million years for just 25 cities, right? So this exponential growth in computational time makes the this enumeration of all possible solution a non-starter. So this is what is genetic algorithm. They are good at taking large, potentially huge search spaces. So if you have so many legal possible solution to any problem, it will navigate around them looking for optimal combinations of things. Then the solution you might not otherwise find in a whole life. So GAR computational paradigm inspired by the mechanisms of natural evolution, including natural survival, survival of the fittest, reproduction and mutation. Right. So we are an example of reproduction. So I have been produced from my parents. So it is an example of reproductions. And my fitness, my skin color, my hair color is nothing but the combination or the gene structure or the protein structure which are being exchanged between my mother and father, which is combination of both, is nothing but it is reflecting in mine. Right. So who has developed genetic algorithm? You can see that genetic algorithm has been developed by John Holland in University of Michigan in 1970s, and these all are the people those who have contributed in the early phases like J. Holland, K. De Jong, and the Kulberg. These three people have made it possible to realize this concept. So this concept has been borrowed from biology, right? And here we have, as I have said, the group of solution. And out of that, you have to combine and you have to find out the one solution. So I'll give you one example so that you can understand it before we see the theories. Okay, so try to see that. So these all are my random parents. Okay, let us consider that I have a 13, 24, 8 and 19, 4 numbers, and this is binary representation of these numbers. And I have decided this fitness or objective function Fi upon sigma f. Right, try to see, this is what is my problem. My problem is what? You have to maximize this function. Okay, y equal to fx, this is nothing but f of x is nothing but x raised to 2, x power 2, it is x square. So I want to maximize y equal to fx, right, which is x square. And this is my fitness function. I have come up with nothing but fi upon sigma f. So second, you can see that I have a 13, 24, 8 and 19. So this is my binary representation of that. Okay, this is my f of x. F of x is what? X square. So this is nothing but my 13 square is 169, 24 square is 576, 8 square is 64, right? And 19 square is 361. So this is what is my total of that. And my relative fitness, this is what my individual value divided by total. So it is 169 divided by 1170, 576 divided by 1170, and this way you can calculate. And this is my overall sum of that. Now you can see that which values you are going to select. Okay, relative fitness. So how many times? This is the fittest individual, so you can select 2 times. Okay, they are allowed to reproduce. This will be selected 1 time. This will be 1 time, but this is not going to be selected because his fitness value is too low. So even if they are going to reproduce the children, due to its less fitness, whenever this particular solution is getting combined with any one, they are going to produce less fit individual. Right? So those individuals which are more fit, they should be allowed to reproduce more number of times. Right? Rather, you can allow him to reproduce twice. So here you can see that I have selected 11000, which is 24 2 times, 11000, 11100. Then I have selected this 01101, 01101, and then I have selected 10011, 10011. So this is my 4. Okay. Now, what I am going to do, I am going to allow this to reproduce. So you can see that this is my gene structure which are going to be reproduced. So there are these 2 and these 2. Out of these 4, I have made the combination and I am deciding one specific part from which the genes are going to be exchanged. So you can see that here if I have decided, then this 0110 is going to remain same, but this 0 and 1 are going to be exchanged. So this is exactly what is going to happen when the child is created from the parents. The protein structure, right, or the genes are going to be exchanged. This is called crossover. This operator is called crossover, right? So this is called single point crossover. You have to define any random point and where the crossover is going to happen. So here I have decided my crossover point should be here. So this 10 and 01 will remain same, but this value after crossover, it is going to be exchanged. So this is exactly what is going to happen when the child is created from the parent. So this is exactly similar kind of thing we are doing here. The same concept we are borrowing from here, right? So try to see what we have done. I have something, okay, this is a maximization function. So I have selected some random parents or this random solution, and I have decided my fitness function, okay. So this is what my maximization function, and this is my relative fitness value I have calculated, and those which are fit individual, okay, I have selected and I have allowed them to reproduce, and I have combined them with the other, okay. So this 0.49 I have combined with 0.14 and another with 0.31. And then I have decided my crossover point from which the genes are going to be exchanged. And based on that, my new populations which has come, and I'm going to convert that into digital value. So this is a binary representation. I've converted that into the digital value. And this value I can check with the previous parents. If they are better than the previous value, I can retain and I can remove the previous one. Right, so I have started with which value? You can see that 13, 24, 8 and 19, and I am ending with 12, 25, 21 and 11. So if these four are better, I can remove the previous four, and now I can follow the next iteration. So this will continue until you can find the optimal solution or the acceptable solution. Right, so this is what is the overall concept of genetic algorithm. So try to see, this is all are the operator. So crossover, right? These are the parents. You can see that there are two parents. When they mate, their protein structures are getting or genes are getting exchanged when they produce the children. Mutation is nothing but any flip to any of the bit. Okay. So mutation means what? Any of the bit can be made from 0 to 1 or 1 to 0 in a hope that this flip bit can allow you to jump, and based on that you can find out the better solution if you are getting trapped in a local optima. This local optima is what? You get an intermediate solution which looks like a final solution, but final solution may be further away, right? So sometime in absence of knowledge, we assume something, we believe something which is not actually correct, right? So we have to correct this, and this, if you have to make computer should correct, then you have to use mutation. So mutation, you have to randomly flip the bit. Okay, then permutation means you can change the order of genes. Okay, so you can see that this yellow, it is here last, I have made it reverse like this. And you can also add or delete some genes, right? So here I have added, you can also delete also. So these all are the various operators which you can perform. Crossover, mutation, permutation, addition, deletion, etc. Right? So this explanation is there. So try to see that. This is my algorithm of genetic algorithm. I have a 4 input. The crossover operator is performed. So you can see that these genes are being exchanged, and based on that you have to calculate the fitness, and if they are better, okay. So from parents I have created the children, and again I have to calculate the fitness. If they are better, then I can again select them from parents. For parents, again they will be allowed to reproduce, and this will continue until you can discover the final result. Right, so this is my algorithm. You have to initialize population. You have to choose how many parents should be there in initial population, evaluate their fitness. Okay, you have to assign the fitness function. This is you have to design, and while termination is not satisfied, you have to select the parents for reproduction. You have to apply the crossover, mutation, permutation, and all these other operators. Okay, and then you have to evaluate the population. If it is better than the previous, you have to keep this newer one and remove the older one. So try to see, this all are the various ways. First, you have to initialize data, initialize population, evaluate the chromosome, okay, select the chromosome, those who are fit, as we have seen in example. How you can select, perform crossover, mutation, and you can have a next generation. Again, you can evaluate if they are better. And this you have to repeat until you can find out the best solution for your problem at the end. So this is right, you have to generate the random population of n chromosome. Chromosomes are nothing but the solutions. Then you have to evaluate the fitness. This is to be designed by you. It is a problem specific. Then you have to create a new population, okay, from the existing one. how you can do? You have to select the two parents, you have to apply crossover, mutation and all other operators. And then you have to accept this offspring or children if they are better than the parents, right? Then you have to replace this new generation with the older one. You have to remove the older one and you have to test if it is your final condition satisfied, then stop, otherwise not, then you go to step number 2 and repeat. Right, so see this, how this operation is actually working. I have 4 parents, okay, I want to perform, so this is my binary and the digit notation. You can see that 13, 11, 4 and 9, 4 numbers are there. I am going to reproduce this, okay. So those who are fit, you can see that I am going to select more than once. So I will remove this 4 because its fitness function was not good. Then I am going to perform crossover. So you can see that the genes are being exchanged between these two. Here also the genes are going to exchange. So you have to decide the location where the crossover is going to happen. Then you can perform mutation. You can randomly flip any bits. So you can see that this 1 I have flipped to 0. You can see there is a different arrow also. And here also 1 is flipped to 0. Okay, in a hope that by clipping this bit I can get better solution. And after that you have a newer one. Okay, so again next time if it is not acceptable you have to repeat this. So this is exactly what has happened when individually we all have been created from our parents. We all have been made from our parents. Okay, so there are gene structure or protein structure which are being exchanged, and based on that the child is being produced, and of course we are better than the parents individually. So this is how you can apply similar concept in finding the real world problem and its solution. This is nothing but your genetic algorithm, right? So see this, these all are the parameters. Crossover probability should be high, mutation probability should be low, population size you have to define initially, and number of generation, right? That is called iteration. So we call our parents, grandparents, their generation, second generation, third generation. So that generation in our case for computer is nothing but the iterations. Right. So these all are the example. You can see that I have a 2 parents and crossover. So this is my crossover point. So this red and blue, you can see that this is getting combined and the child is being created. Same way the other child of these two is getting combined and being produced. Mutation, you can randomly flip any bit from 0 to 1. You can see. So when parents meet, their protein structures are being exchanged like this gene structure, and in children, like, so see that your skin color, your eye color is nothing but the combination of, this is how the children is getting produced from the parents. Okay, when the parents mate, their gene structures are getting exchanged through crossover, and this is how, so same concept we are applying here, right? So this is called reproduction through crossover and mutation. These are the 3 basic operators. Right, these all are the concept what we have discussed. Population, chromosomes are nothing but the solution, individual bits are called genes, and the overall string is called genotype, and the actual driver of genetic algorithm is a fitness function, right? So which is a problem dependent. So for traveling salesman problem, distance travel should be minimum is a fitness function. For next step problem, the maximum number of objects which can fit in your bag can be fitness function. So it is problem dependent. We have to design, and this is nothing but the main driver of genetic algorithm. So solutions evolve via trial and error, okay, and it is suitable for the complex applications. So I hope I have made it clear about the artificial intelligence, which are the topics what you have to study, what is the difference between AI, ML, DL, and what is genetic algorithm, right? What is search and optimization technique and how GA fits in that. So all this concept, whether you talk about human brain and everything, is borrowed from the real world only. If you have any questions, you can ask. Hello?
Yes,
Any
sir.
questions?
Please raise your hand, those who want to ask the question, and then turn on your mic and ask the question. Please turn on your mic and ask the question.
Okay, so if you don't have any question, we'll stop.
Students who are having any question related to artificial intelligence genetic algorithm, they can ask her by turning on their mic. First raise your hand, then you can turn on your mic and ask the question.
Fine then.
Thank you, sir, for enlightening us. It was a very great session.
Okay, fine then, all of you. Take care.
Thank you, sir. According to my count, 125 students are there. I'm taking their attendance. So these students are allowed in my next lecture and Chirax's next lecture. The other students are not allowed. Give a valid reason why you're not attending the expert talk. Thank you, students, those who have attended us. Thank you for the cooperation. You can find the recording in the chat. Yes. Anyone? I'm terminating the meeting. Thank you.